Like I promised, welcome to another segment of my physics O-level, videos. I still continue with current electricity, but I'm looking at another segment called electrical resistance. So we're going to look at electrical resistance. So the question that we can ask ourselves is, what is resistance? Well, when we talk about resistance, we can simply define resistance as simply the opposition to the flow of electrons along a conductor. So when there's opposition to the flow of electrons along a conductor, we call that one as being electrical resistance. So we can write and simply say electrical resistance, maybe I can put up a point, opposition is the opposition to the flow of electrons. So the opposition to the flow of electrons along a conductor. So that is what we simply call as being electrical resistance. So some books, they're just going to be saying resistance. That's fine. So it could be the interference to the flow of electrons along a conductor. That is what we simply call as being resistance. Now you should be thinking of it this way. Remember that if you have a conductor, and in this conductor there are electrons that are moving. So if the electrons are going in that direction and there's that opposition, or they are being interfered with such that they cannot move properly, that is what we call in physics as being electrical resistance. Now, you need to remember that electrical resistance is actually measured using an instrument called an ohmmeter. So what instrument can be used to measure electrical resistance? So the instrument used for measuring, so the instrument used for measuring, electrical resistance, is called an ohmmeter. So we call it as being an ohmmeter. So that's an instrument that is used for measuring electrical resistance. Now you need to remember that in a circuit there are devices that are designed to offer resistance, and that is what we call as being resistors. So we can maybe say that devices that are designed to offer resistance in a circuit are called, so we call them as being resistors. So these are devices that we put in a circuit that actually offer what we are calling as being electrical resistance. What's the circuit symbol? Well, the circuit symbol for resistors in a circuit that we normally use, we can either use that's the circuit symbol, or you can use that's the circuit symbol. When you find that, these are going to be representing what we call as being resistors in a circuit. There are devices that are designed to offer resistance in a circuit, that opposition to the flow of electron along a conductor. Now later on we are going to look at arrangement of resistors. There are two types of arrangement of resistors, but before I look at arrangement of resistors, I want to simply talk about maybe first of all the unit in which resistance is measured. So what is the SI unit in this case for resistance? So resistance is measured in ohms, so we use the symbol omega. So omega, ohms, they're represented by the symbol omega. Ohms is the unit in which resistance is measured. So like I said, we are going to look at arrangement of resistors later on, but at this point I want to talk about factors affecting this electrical resistance. What are some factors that are going to be affecting this electrical resistance? So we can simply say maybe factors affecting resistance. So what are some factors that are going to affect this resistance that we have talked about? Of course, if you remember, if I can just take you back from what we learned under Ohm's law, we know that resistance is equal to voltage divided by current. But I also want to highlight to you that as you advance, you may also come across what we call resistance can be equal to what we call resistivity. Then you are going to find L over A. So we can actually express where this one is a constant that we simply call as being resistivity. You're going to find that. But that's L, the length, and that's the cross-section area. But of course, from Ohm's law, we remember that resistance is voltage divided by current. So let's quickly talk about factors affecting resistance. So I can highlight to say there are 4 factors maybe that I can give you affecting resistance. One, we can simply talk about the length of conductor. So the length of the conductor does affect what we are calling as being resistance. Now how does that happen? Well, when you look at the relationship between resistance and length, the way it is that resistance is directly proportional to the length of the conductor, meaning that if you increase the length, it simply means that the more opposition that you are going to have. On the other hand, if you were to reduce the length of the conductor, it simply means that you are reducing what we are calling as being resistance. So that's the whole idea. So meaning if you have got 2 conductors, one is longer and the other one is shorter, it simply means this is representing the length there, and that is representing the length of another. If this is A and that is B, it simply means that when you make the length to be longer, it simply means that you're also increasing the resistance. No wonder sometimes some of you trying to do MacGyver method, you actually make your charger to be longer. You want it to move from the socket to go all the way to outside. You increase the length. What are you doing? You're simply increasing the resistance in the circuit. And the phone will take longer, to charge. The second factor that we can simply talk about is the cross, section area. So the cross section area of conductor. So the cross section area of the conductor that we have, others would actually simply say the diameter. So they can say diameter of conductor. That's all right as well, diameter of conductor. Now how does this factor affect resistance? Well, the cross section area, resistance is inversely to the cross section area. So it is inversely to the cross section area, meaning when you make the area to be big, you are simply reducing the resistance. On the other hand, since resistance is inversely to the area, we mean when you make the area to be small, you're increasing the cross section. So look at this. In case you have got 2 wires and the cross section area there, you have got a bigger one, the cross section area, and you have got a smaller one there. Let me call A1 and A2, because this conductor has got a bigger cross section area. What have we done? If we increase, it simply means that the resistance will be reduced. But in the smaller one, electrons will not be passing properly, and hence you are simply increasing the resistance. So the cross-section area of the material. Another factor that we can simply talk about is simply temperature. We can simply talk about temperature. So we can talk about temperature of a material, temperature of material or the conductor that you have. So how does temperature affect that? Well, temperature is actually directly proportional to the resistance. So the resistance is directly proportional to the temperature, meaning again that if you increase the temperature of the material, you are simply increasing the resistance. And on the other hand, it simply means that when you reduce the temperature, you are reducing the resistance. And that is why when we stated Ohm's law, we say that constant temperature. Why? Because temperature is affected by resistance. The last but not the least we can talk about is simply the type of material. So what type of material? The type of material that you are using. Yeah, some materials are better conductors of electrons than others. That's what you need to remember. Yes, some materials are better. So they are actually better conductors. They are actually better conductors of electrons. They're better conductors of electrons than others. For example, copper, is a very good conductor of electrons, and that is why we actually use it, in most every day. But I'm not saying it's the best, no, not at all. There are other materials that are actually better conductors. So the type of material that you use, so factors affecting resistance, the length of the conductor, cross-section area, so we are simply talking about just the cross-section area of the conductor, the temperature of the material, and also the type of material that you choose. E.g., others may prefer to use copper, others may prefer to use silver, but if you look at materials like nichrome wire, nichrome wire has got a high resistance. Yes, it has a high resistance as compared maybe to copper and silver. Well, thank you so much for paying attention to my lesson. See you in the next lesson when I talk about arrangement of resistors in series and in parallel and how you can go about some calculation.